Hello everyone, I am Mrs. Hema Sagar Kumbar, working as Assistant Professor in Department of Computer Engineering, PICT Pune. Welcome to the video lecture series related to the database management system, and in this video we are going to discuss about the second normal form. In my previous few videos we have discussed about the normalization and the first normal form, and in this video we are going to discuss about the second normal form. Second normal form, the requirements of a relation to be in the second normal form are: it has to be first in the first normal form. The relation has to be first in the first normal form. Then the second one is every non-prime attributes must depend on the whole primary number, not just a part of it. In other words, there should not be any partial dependency of any column on any part of a composite primary key. 2NF helps to eliminate redundancy caused by the partial dependency and ensures the data integrity. So basically the relation to be in the second normal form, the very first rule is that has to be in the first normal form. And second one is every non-prime attribute should be depends on the whole primary key, not on the part of it, which is called as a partial dependency. So first we'll discuss about what is a prime and non-prime attribute. A candidate key is said to be a minimal set of attributes that can uniquely identify a tuple in a table. Suppose for example I have a relation which is said to be as a R, which do have three attributes like A, B and C, and functional dependencies present on that relations are A as to B and A as to C. So in turns, A is said to be a candidate key of a relation because A identifies all other attributes of that particular relation. A identifies B and A identifies C. So A is said to be a candidate key for this particular relation. A prime attribute, hence A is said to be a prime attribute. So a prime attribute is an attribute that is a part of a candidate key of a relation. So A is a prime attribute over here. It may be case that a attribute or a candidate key may be a combination of more than one attribute like AB, AC, ABC. So all those attributes are said to be as a prime attributes. In turns, values or the attributes which are present in the candidate key are said to be a prime attributes, and all other attributes are said to be as a non-prime attributes. A non-prime attribute is an attribute that is not a part of a candidate key. So in this case, B and C are said to be a non-prime attributes. So also we discuss about the partial dependency. So partial dependency occurs when a non-prime attribute is functionally dependent on part of a composite candidate key. Composite in the sense of it does have a more than one attributes, not only a one attribute. Like in the previous case we have A as a prime attribute. So here it could be a case like A, B are the prime attributes which are the part of a candidate key. So partial dependency occurs when any non-prime attributes depends on a part of a candidate key, so that is a partial dependency. Let us say for example I have a relation like R which does have three attributes like A, B, C, and functional dependencies present are AB arrow B and A as to C. So here AB are said to be a candidate key because AB identifies all other attributes of the relation. So AB is a candidate key of above relation. So in turns A and B becomes a prime attribute. So here A and B becomes the prime attribute and C becomes my non-prime attribute. So according to this, so A, B, arrow B, it means the B is been identified by all the prime attributes, not on the part of it. So here is no any partial dependency. But if at all you see about here A arrow C, C is been identified by part of a candidate key. C is been identified by only C. Only C is been identified by only A, not A, B both. So here is said to be as a partial dependency because of A arrow C. Because C, which is a non-prime attributes which is identified by a part of a candidate key, here it is A, not both A and B. So A and C are said to be in a partial dependency. So to be in two, so let us see now example of a relation which does have some kind of partial dependencies and which violates the concept of the 2NF. So partial dependencies arises when any non-prime attributes depends on the composite, it depends on the part of a composite primary key, and which causes the redundancy. Let us consider I do have a relation in which I do have columns like attributes like order ID, product name, and the quantities. So if you observe this relation, I can easily find out the functional dependencies present in this particular relation. The very first is order ID and product ID identifies product name and identifies quantity. This is the one functional dependency present. And another functional dependency I can observe is like product ID identifies product name. The product ID identifies product name because for unique product ID I do have unique product name. So I can identify the primary key of this is a order ID and a product ID. So hence they become my primary attributes, and remaining all attributes becomes my non-prime attribute. In this case those are product name and the quantities. Those are my non-prime attributes. So here is one more functional dependency present which is called as a product ID identifies product name. But product ID is my non-prime attribute and that is been identified by the part of a candidate key. So this is a partial dependency present because the product name depends only on the product ID, not the entire candidate key, order ID and product ID. So hence the relation is not in the 2NF. So what we have to do? We have to convert this relation into the another form of the relation, another form of the tables which will follow the 2NF rule. We have to decompose our relation into the smaller tables. So now we'll tell you about the thumb rule for the decomposition. So basically what is decomposition? Decomposition is dividing a relation into number of smaller relations which will be lossless. Because what is lossless means because of I am dividing a table into number of smaller relations or smaller tables, I am not in a state of losing any kind of information because of that decomposition. So when I do join all those decomposed table to get my, I should get the original table. So that is called as a lossless join decomposition. So I'll tell you one thumb rule for the decomposition which do applies for all the forms, all the normal forms. Like suppose any kind of relation which is not following, not in the form of any kind of normal forms, we have to divide it into the we have to rather decompose it. So this thumb rules applies for all those relations in which we have to convert a relation into the normal form by decomposing that particular relation. So suppose I do have a relation R which have a functional dependencies like x identifies y, and that is a functional dependency which violates the rule. So we have to identify one such functional dependencies of that particular relation which violates the rule to be in that particular normal form. After that what we do, we calculate x plus and y plus. So x plus means the closure of the x and y plus is the closure of the y. So hope you know the meaning of the closure of particular attribute. So then we have to consider as R1, that means first decomposition, that is equal to x closure of x, and second decomposition as R minus closure of y. Let us say for the example, as in we are discussing about this example. So here is which we have to first identify the relation which violates our rule. So in this case, this relation, this function dependency I do have in my relation which violates my rule to be in 2NF. So I'll take that one. So here is this becomes my x and this becomes my y. So in that case I have to calculate x plus. So that is product plus. So product plus is like the product plus means a closure of this attributes product plus. So find out all the attributes which are identified by that particular attribute. So the attributes which are identified by product IDs are product ID and product name. And second y plus is product name. So product name closure. So find out all the attributes which are identified by product name. So in this case product name is been identified by product name only, because there is no any other attributes which are identified by that particular attribute. So this is the closure of the product name. So hence the decomposition will be, so r1 is equal to x plus. So x plus is my product id plus, that is nothing but order id comma product name, and r2 is equal to r minus product name plus, so that is equal to order id, product id and the quantities. Now my table is in 2NF, which does not have any kind of partial dependencies. So I have decomposed my relation into two sub relations. One is relation 1 and relation 2. And relation 1 contains the attributes like order ID, product ID and quantities. And second relation does have attributes like product ID and product name. And accordingly this is my decomposition, which is obviously the lossless decomposition, because if I do join these two tables I will definitely get the original one. And thank you, see you in the next video.